am the lead, and my support team members are Partha, again, who is assistant manager for customer engineering and corporate quality, and he's Taruna, the deputy manager for supplier quality team, and he's also part of our corporate quality. So I'll be presenting the second project for the same OEM and a different failure mode. So this is a project again which we have taken in one of the supplier site at Tokyo, and this project title is failure mode stain reduction from 7.5% to 5%. Actually this is a greenbelt project, we have not used much tools, very simple tools, and this is a short term project. So problem statement. So stain was one of the top failure modes. So when we did an Pareto in the final inspection process, stain was the third failure mode. So AR pinhole was the first failure mode which I presented in the morning, and to get huge improvement in the yield, we parallelly run multiple projects for the same project. That is for CID 20. It's called a CID G20 program or the glass. And so what we did is we collected this stain failure mode in all the processes. So we had stain failure mode right from cut-in process, anti-glare, print-in, anti-reflection and final inspection. So all study where all this scratch is getting generated in all this process. So current status 7.5, desired status is 5%. Critical to quality to meet quality requirements, enhance the delivery requirements, and overall to keep the customer happy, and few more new business wins. Cost savings for this project, a cost of poor quality was $0.83 million US, and other things is customers they were escalating too many things up to the CO level. So there was a need for us to run critical projects at the OEM for different failure modes. Defect definition, stain reduction, and so some of the probable causes, it could be due to dirty wiping cloth, no periodic cleaning of vacuum suction chuck cover, then they were using a lot of gloves which were found contaminated, and then lot of improper cleanliness of the wiping table, inspection table. We had a project timing plan, so we plan to complete this project in 10 weeks time, started in calendar week 13 and we finished in calendar week 22 of the current year. So cost of poor quality, so during our defined phase, so many parts were rejected, so many 850 parts were found rejected, and the projected savings for this project is estimated customer demand volume 53,000 parts, annual volume 6.5 lakh parts for this, total saving $0.83 million US. Now I'll hand over to Partha to walk through the measure phase. Thanks.
Yeah. So this is in terms of measure phase. So again the data was collected and it was plotted with respect to the stain. So here the percentage we are showing the trend of stain reduction percentage. So the target which we have fixed is 5%, and we are running it around 7.5. And on average it is baseline, it is 7.5. So this is the trend we have plotted in the calendar week, as earlier she explained. So this is the Pareto chart showing at stain, the contribution of stain, the overall rejections in this. So stain is in the third top failure mode, contributing of around 13%. So I'll hand over to Shashi for. Karna will take care for analysis.
So sorry, it's analysis phase.
Yeah, analysis you can do.
We carried out the brainstorming for 2 days, and also as part of the analysis phase we also went through the Gemba walk. So we were all located at the supplier side. We had an opportunity to do daily Gemba walk. So it was more of observations, what's really going in the handling and storing of the parts. So after the brainstorming we carried out a cause and effect diagram. So under man category we identified there were a lot of stain caused on the AG side. So that was one of the cause, and then we found a lot of ink stains found on the flat printing table. Then we found there was a dirty vacuum suction handling jig. The jig was contaminated at the loading station. Then we found the vacuum suction chuck cover of the wiping stand. So they have the wiping process where they clean the glass surface. So, that was also found contaminated, and we found some of the hand gloves being used by the operators. There were no good controls for replacing the gloves. We found a lot of hand gloves which were found was not as per the requirement, and then they had an horizontal conveyor, even that was found contaminated, and then again they had another wiping stand at the loading process. So, improper wiping method of the way they were handling the method, that was not appropriate. Then again, as part of the analyze phase, what we did is for 1 week's production, we collected all the defective components for this stain, and we did a quick analysis. We started doing the concentration diagram where all stain is located. So, here we can see this is a detailed analysis. So, this is a curved glass which we developed for BMW. So, we plotted concentration diagram, and this itself, it was a huge effort because we need to do concentration diagram, all this we completed. So, this helped us to find where all stain is getting created. So, it was found in cutting process, AG, anti-reflection process, including final inspection process. So, we can go through. So, we also plotted a Pareto to find the categorization of stain. So, if you see here, it is evident that 35% of the stain, it was found on the AG layer. And then we found 14%, it was again found on the AG layer. This was due to ink adhesion. So, we continued this analysis. So, we could see that stain was spread across. It was on the curved surface, it was on the flat surface. So, this is again on one particular day the stain defect was very high. Again we did a concentration diagram. So, it was spread across on the flat surface as well as the curved surface. Then we did a simple 5-way analysis for this project. So, here stain was very high in the printing process. Then we found it was because they were using a chat mark. There was huge chat mark on printing side and in the open window area. And then this was because of dirty vacuum suction handling jig at loading station, and this was action we planned. So, we stopped usage of the vacuum suction handling, and because that fixture itself we found handling that was huge. So, then we instructed the operators to load the glass manually using a good hand gloves. So, this really helped. Some of these actions really helped. Then again we found that the stain was high after the plasma cleaning. So, that was huge. Again it was because of vacuum suction chuck cover of the horizontal conveyor. So, then here we established a cleaning frequency that they need to replace the vacuum suction chuck cover once in every week, and then we updated the control plan as part of this action. And after establishing the cleaning frequency, we updated the work instruction and we rolled out training program to all the operators. And then similarly we also found the vacuum suction chuck cover was dirt, and so here also we established a cleaning frequency. So, all this was more because of handling interference. So, we established work instructions, rolled out the training program. Again we found high stain was in anti-glare process. Again here the hand gloves was contaminated, it was due to lot of dirt. Here also we established a cleaning frequency that they need to use fresh or new gloves after every 240 parts. They have a batch size of 240, they need to replace. So, again they had a glass wiping stand, so the contact surface was contaminated. So, here also we established a cleaning frequency. They need to change the cover cloth at the loading process on a daily basis, because before this project they were replacing once in a month. So, now we established a frequency, it is like every day. Again here we studied the stain category, and also there was no feedback mechanism. Like whenever the operators are doing attribute or visual inspection, so there was no feedback to the operators, because every glass is subjected to cleaning, manual cleaning. So, there was no feedback. So, then we reinforced a sort of feedback from the printing process. So, whenever the stain category is very high, they need to give feedback from the printing process to the wiping operators. So, the operators are cleaning. So, this also as a continuous improvement we implemented. So, it was like very good feedback will flow to the wiping operator. So, they will improve the wiping method. So, then we found ink adhesion, again this is a different type of stain which they found on the AG side. This is because of improper wiping of glass. It is all manual wiping, cleaning. So, we improved the wiping process by again reinforcing training to all the operators, updating the still metrics. Then we found there is a flat printing table. So, that was completely accumulated with lot of ink stains. So now we established a frequency that this flat printing table, they need to have visual checks and ensure that it is always kept in clean condition, and we developed a check sheet for performing this. So now I'll hand over to Karuna to just walk through the improve action plan and provide the status.
Yeah, good afternoon. So whatever we identified the potential root causes, then we took some corrective action to improve, because we cannot prevent these stains and dirt in the manufacturing industries. So whatever the possible corrective action we could take, that is what we implemented over here. So one is for the dirty vacuum section, that's in the jig area. That's actually chuck mark which we used to provide in an automotive stage. So actually we avoided the automotive stage, because, and also this is a closed loop section, so we can just manually we can upload, but then we cannot interpret, the operator interference is not there. So unless, until we get a final product in the assembly. So here actually we just manually implemented for uploading and glass into the chuck. And also the wearing, we advertise about wearing clean hand gloves. And the second one is about plasma cleaning. This is actually part of an inkjet process. So there where due to dirty vacuum section, whatever the, it's an automated process, because after plasma they go for a front and back end inkjet process. So since it is a closed loop section, we cannot do any manual over there handling. We cannot do any manual handling. So again, it's just cleaning of chuck over in the horizontal conveyor, and we updated all the work instruction and provided the training to the operators. So this is stain caused due to the vacuum section in the wiping standard. Actually, after inkjet process, there is a process called wiping. So in both flat area as well as curved area, the operator has to wipe the ink, because it will get spread over in the end of the glasses. So while doing the wiping, there may be the chances of the wiping cloth get touch on the glass surface. So that gives the stain cost, but so it can be improved only because of training to the operator and ensure their skill matrix and skill level. So since it is a critical area, so we update the work instruction, provided the training to the operator, and also we updated the frequency of sections chuck cover cleaning. So before start of the shift, every day they have to clean the chuck, before kickstart the process. So this is used to cut off dirty hand gloves, because it's everything is this issue is manual handling issue. So we established the frequency for each tray. That can be only 240 parts can be allowed. So whenever they are changing the rack, they have to clean immediately. So it was not there. Actually, they used the whole entire the shift. So it has been improved now. And also we provided some visualization. So how to handle the when they have to remove the gloves, and how to handle the racks. So this is again dirty on the contact surface of glass. This action which has been implemented instead of automated. This is where we can only we can do the manual interaction. So this is including all the section chuck cover. Wherever the chuck cover cleaning is improper cleaning we found, we updated. Since it is Japanese, so just we are giving some. Okay. So this is the frequency change for the gloves. Okay. So this is the feedback communication has been provided to the respective previous operator or previous station. And this is actually given some visualization where we need to how to hold the parts and each and every stage, and where we need to wipe. That this instruction has been improved. This is a skill matrix. So we are using only the updated, all three has been green, blue. So that particular operator only can do the particular wiping process. Earlier it was everybody. So in industry every day the new operators coming into the picture. So it has been improved. It has been avoided for the particular station for the wiping alone. This is the area that chuck cover. They are placing the component. This is the glass actually. So the frequency and changing the glass chuck cover cloth. There is another tape over used for keeping the glass. that has been the frequency of changing this paper or cloth, that has been improved now. So this is a cleaning mechanism, how to clean, that has been automated. And I am just giving the before and after stage. Before cleaning the ink, how it has been spreaded, and this while handling this can be influence the dirt. Yeah, thank you.
Thanks, Krishna. So I'll just quickly go through the control phase. So after implementing set of 11 action items, all were implemented, and also it was sustainable at the supplier end. After implementing, we could see that there is a significant reduction in the trend. So it was like 7.5%. We had a lot of spikes, and as a result of improving, we can see a decreased trend. So we have overall achieved 4% stain failure mode. Even though we set a target of 5%, we have achieved 4%, and 2 months back we got an update that they were able to reduce to as low as 2% after consistently implementing all these action items. We also statistically validated using the two proportion tests. So we can see before improvement, calendar week 6 to 12, and after calendar week 13 to 22, this is an improved state. So null hypothesis is rejected. So this is an improved process which is statistically validated. And also as part of the control phase, we also updated the PFMA because it was more of manual actions and replacing the hand gloves or replacing the vacuum suction chuck cover. So the PFMA was updated, all the actions were planned, implemented. And we also updated as part of the project the control plan, and it is released to the supplier. We have reviewed and updated. We have also signed off the PPAP after implementing the actions, and also all this part of the documents. So we did the knowledge sharing. So we also called the other representatives of suppliers, so they're able to replicate these type of similar actions to the other process, because they have several other programs or projects, and we also shared to the OEM. So we received appreciation note from the quality directors of Visteon, as well as we also received from the OEM. So this is a summary of all the tools which we have used in this project. So we have used a problem statement or Pareto, then we have set the CTQ, then we use the Pareto to understand the top defects, brainstorming, cause and effect 5i, then improve action plan, then we did the trend chart, updated the AG tools, PFMA control plan, use the two proportion test. So this is a summary of the tools being used. And this being a greenbelt project, we did not use any complex tools, and due to time constraint, we just did the Gemba or shop floor work and implemented using simple tools. But this gave a very good cost savings. Projected saving was 0.8 million US dollar, but we were able to achieve close to 2 million US dollar because of the increased volume we won from the OEM. Okay, thank you.
If you see that your problem is stain, only two stain is always will come, because where chuck cover, that is fixed stain, it will come to that area. Apart from that, you have reduced from 7.5 to 5%. The stain location, is any variation is there between the earlier process and now wiping process, even though you introduce change of gloves with the defined frequency and wiping methodology or cloth changing everything? The location of the stain, is any changes there before and after?
Yes. Yes, it has been improved. Earlier it was more on the flat surface. Now it has significantly reduced because of the improved wiping method of the glass, and also they have replaced all the gloves. We have an established frequency for replacing the wiping cloth, the hand gloves, and also they started cleaning the flat printing table. So there was a lot of ink stains accumulated. Now they have established a frequency. Beginning of the shift, they clean all the flat printing tables, so that way they are able to eliminate all the flow of ink stains. So it has significantly reduced on the flat surface of the glass.
She is right, actually. So in the flat surface, we are able to implement some action in the chuck cover. So the frequency of changing the chuck cover.
Because that is a fixed location.
Yeah,
Yes.
that has been reduced,
Yes.
has been reduced now. But fortunately, we are not able to reduce much in the curve area. That normally operations doing some lighting. So that we cannot avoid 100%. That is.
No, can I take that 5% only from that particular area?
No, not 100%.
5% it is spread across.
No, what is now existing, what you are achieving is that only from that area?
Yes.
Or similar kind of stain will be there.
No,
If we check any component, the stain area will be only that particular area.
That's actually not 100%. I can
It
say
is spread across it.
88% it has been reduced from the flat area.
Okay.
So now the more actually contributed from the show area.
Because here it's more of manual cleaning. So if the operator is not cleaning, he'll try to clean on one side of the surface, the other side if he doesn't do. So and also here automation is not possible. We are planning for the robo cleaning, but it's again a lot of investment. It may take some time.
This 5% again you are putting back into operation by further cleaning, right?
Is it rejected or scrapped?
Or again further you will further clean and you will use
Yes,
it.
further cleaning they will do. Further cleaning they will do. Again the recovery is very less.
No, means then we cannot say rejection, no? Because you are salvaging and you are reusing. No.
Actually for understanding.
Yeah.
Actually we are holding the component like
Yeah.
the curve area should be like these are the flat area.
Okay.
So in operator cleaning there will be a possibility of the cloth dirt can be deposited on the ink area.
Yes.
That is what we are not able to completely prevent it.
Okay.
Okay. So once any dirt find in the inspection area,
Yeah.
so that possibly rejected.
Yeah, his question is whether these stains are found in the final inspection. So it will go for scrap.
That's what I was
Yeah, yeah.
It
So
goes for
again,
scrap.
you're not
We
scrapping,
cannot
right?
recover. If it is in the printing process, we are able to recover. But whatever this project is focused on final inspection. But however, we implemented actions, understanding the root cause in the respective process.
Not allowed in the final.
Right from cutting, anti-glare, anti-reflection, we implemented in all the process the corrective actions.
I have only two observations. One is you are being very open that the rejection is so high as 4%, 4 or 5. First is the stain, can it be made zero or no?
Yes.
Is there a possibility of zero stain or no?
Yeah, zero could be very difficult.
No, one, like that is a TPM target. No, this for me was a Six Sigma project for SOP implementation. I will call this a Six Sigma project for SOP implementation.
Yeah.
The other thing is skill matrix. You have drawn this, no?
Yes.
How will you evaluate an activity like cleaning and say somebody is good, somebody is bad? What
So
was your
here-
measure? Was it objective? Was it subjective? And who was the person who says, I am the best person to clean? Is there a sensei? Since you have said Japanese, no? Is there a sensei in cleaning who says this is the way to clean? So, what I am saying, is there a standard? I wipe 7 times like this. He said, no, I am holding like this.
Yeah.
Hold only like this. The other thing I want to know, how many times is your product handled by a machine and human being, not operated upon?
Yes.
Can you not reduce that?
Suppose that it's critical.
It's possible. Already this.
Too much time.
Yes, I know. Yeah, already this supplier has implemented a lot of robots, and he's further planning to implement robots. Again, it calls for investment. So since there's this new business, he's planning to implement robots in the next 6 months. He has a long-term plan for that.
But it's a nice learning for me in terms of Six Sigma for SOP.
Yeah.
Thank you.
Thank you. Thanks.